Okay, so we want to now use the quotient rule to simplify. And before we do that, I want to recall to be simplified, there were three conditions, right? The radicand can contain no perfect square factors. And that's what we've been doing here. And I gave these two examples. Then we said there can be no fractions under the radical. The problem is when dealing with this, we don't want to wind up with this, a radical in the denominator of a fraction. Now, later you will learn how to deal with that, but right now we don't know how to deal with that. So we're going to try to avoid that like the plague. Okay? So the quotient rule is very similar to the product rule. We just have one additional feature, and that's that b can't equal 0, and that's because we can't have a 0 denominator, right? So the quotient rule tells us we can pull it apart and push it together, my little accordion, right? If the denominator is a perfect square, we want the numerator and denominator under separate radicals. So we want to break it apart if it's all together. We're going to simplify the radicals, and then we'll simplify the fraction. Now, on the other hand, if the denominator is not, it should say is not, a perfect square, then we want the entire fraction under one radical. That's an E. See, I can hear the board writing. Now what we're going to do is, here we had to simplify the radicals and then the fraction. Now we're going to simplify the fraction and then the radicals. Radical. Actually, you only have one, actually. Okay, I'm going to move it down now. So let's look at an example. This first one, is my denominator a perfect square?
Yes.
Then I'm going to separate them. Could it work out if I don't? Yeah, it could. But at this stage, you don't have the way to determine it, and what's going to happen is you're going to get really confused. So you're better off with a straightforward rule for now until you learn what to do when you're stuck with a radical in the denominator. So right now, if I move them, if I use the quotient rule right now and give them their own square roots, I'm guaranteed not to wind up with a radical in my denominator. Okay? And that's what you need right now. And now we simplify our radicals, and then we simplify our fraction. Okay. It's tempting to just do the denominator here since that's easy. What's the square root of 9?
33.
Okay. The square root of 72. Two radicals, perfect squares. What's left? What's the biggest perfect square that goes into 72? Any idea? It's not 9. Let's see. Yeah, I wrote all over the board, didn't I? 9 goes into 72 how many times?
8. Or 36.
9 times 8 is 72, right?
Right.
What perfect square goes into 8? Into 8. Into 8.
Oh, 4 and 2.
4. Okay, so this is really 9 times, and we'll say that's 4 times 2. A perfect square times a perfect square, guess what? It's a perfect square. The biggest is 36.
Oh.
36 times 2 is 72. That's the easiest way to me to find the biggest. I find the one I can see, and if there's another perfect square, I factor it some more, and I multiply all my perfect squares. Does everyone understand what I did there? Not really? Okay. I looked for a perfect square that went into 72, and I didn't see 36, but I saw 9. So 72 is 9 times 8. It wasn't the biggest because it's still a perfect square and what's left. So I keep my 9, but I factor this. I say, okay, This is the perfect square 4 times what? Okay, 4 times 2. So here I have 72. 9 times 4 times 2. These perfect squares, when I multiply them, that's 36. These numbers multiplied is 72. And when I take the perfect squares part, I get the perfect square, the biggest perfect square factor. Okay, so we have square root of 36 times the square root of 2. Where are you? And now, the square root of 36, that's a perfect square. We planned it that way. The square root of 36, well, that is 6, right? So we have 6 square root of 2 over 3. So far, what we did was, there was a perfect square in the denominator. We broke it into 2 radicals. We then simplified our radicals. And now what do? Simplify our fraction. So 3 goes into 3 once, 3 goes into 6 twice, and we're left with 2 square root of 2 over 1. So I'm just going to write 2 square root of 2. Ew, running out of room here. Okay. Let's look at the next one. Is the denominator a perfect square? So we're going to break it apart. Simplify our radicals. Well, square root of 9 is easy, right? That's just 3. What about the square root of 6? What's the biggest perfect square that goes into 6? No perfect squares there, though. You can't do anything with that. It is in simplified form because it contains no perfect square factors. You only have to look at the numbers below it. 1 we don't look at, so what's the next perfect square? Say? That's not a perfect square, though, is it?
What if you put 3 square root of 2?
But that won't help you, because you're just trying to get rid of perfect square factors. It has no perfect square factors. Go to your perfect square list. What are your perfect squares? You have 4, because that's 2 squared, 9, because that's 3 squared, 16, 25, right? None of these go into 6. And the only one you would check is this one, because you're only going to check things that are smaller. 9 can't go into 6 and even integer number times, right? So you would only check numbers that are smaller. It has no perfect square factors. That's it. We're done. Now, what about canceling? 6 and 3 have a common factor of 3. Can we cancel? No, he's in jail and he's not. They don't consort. We're done. Next one. Is 3 a perfect square? Is our denominator a perfect square? No. Then we are not going to break them apart, because if we do, we're going to be stuck with a radical in the denominator that you don't know how to get rid of. So we're going to simplify our fraction and hope that that helps. What's 27 divided by 3?
9.
So now we get the square root of 9, which is 3. Okay, now they're getting nastier, right? Look at your denominator and don't say it aloud. Decide whether it is a perfect square. If it is, break it into 2 radicals. If it is not, try to simplify the fraction first. You're only looking at the denominator now. Is 2x squared a perfect square? You have to look at the 2 and the x squared. They both have to be. Okay, somebody tell me, is 2 a perfect square?
No.
Then I don't care if x squared is, because the whole thing is not. So, if the denominator is not a perfect square, what do? Simplify the fraction first. We're going to look for some common factors and hope to make that non-perfect square disappear. All right, well, let's look at the numerical part. Let me find my pen. There it is. 2 goes into 2 once. 2 goes into 8. I'm going to put it up here, but it's under the radical. Okay, I just can't fit it. How many x's can we cancel?
4.
How many?
3. I mean, 2.
Okay, we get rid of these 2. If we get rid of 2 of these, that leaves 3 of them. So what are we left with? The square root of 4x cubed. Is that what that is? I can't read my writing. Over 1. So that's really the square root of 4x cubed, right? We got rid of the denominator. That's what we wanted. Now we can simplify the radical. How do we simplify a radical? We set up 2 radicals, perfect squares, whatever's left. Okay, look at your number. Decide what goes in the perfect squares radical and what goes in the other. No. Give me a perfect square in here. Only perfect squares should go in here. 4 is a perfect square. You're trying to square root it. Don't square root it yet.
Okay.
Okay. What's left to go over here then? Well, no, I'm talking the numbers. If 4 went in here, I'm not going to put anything in here. If I had to, I'd put a 1, right? Because the product should be this. How many x's can go in? 2. And what's left? Okay, you created a radical with all perfect squares. Now it's time to square root. And you should be able to square root it. The square root of 4 is, square root of x squared is. Can't do anything with this because it contains no perfect square factors. Oh, goody, we're going to hear a video. That's it. Next one, look at your denominator and don't say it aloud. Is the denominator a perfect square? You look at the 16. If it is, then you look at the a squared. If it is, you look at the b to the 4th. The denominator is a perfect square, therefore, separate. So we want the square root of 20ab. We're separating, we said. So we want the square root of 20ab over the square root of 16a squared b to the 4th power. And now we simplify our radicals and then simplify our fraction. Well, the denominator is easy, right? They're all perfect squares. So we get 4. What do we get here?
A.
And here?
B
B to the 2nd. The numerator, however, we need our 2 radicals, perfect squares, whatever's left. Okay, take a look at 20. What's the largest perfect square from your chart that divides into 20? Your perfect squares are 4, 9, 16, 25. 4 is the biggest. What's left?
5.
How many A's can we put in here? Where does that go? Okay, we can't put any A's in the perfect square. We don't have an even number of A's to put in there. They all go here. What about the B's? B goes here too. You can only put even powers of exponents in these perfect squares.
So the bottom of 4, would that be 4a squared?
Where are you? Here?
Yeah. No?
That came from here. We're up here now. You may want to in the beginning, and as a student I would have done this. I would not have done this numerator in place. I would have done it off to the side. I would have taken this off to the side and figured out what is the square root of 20ab. Because doing it in place like this is confusing. So now we have our perfect squares. What's left? Well, we said 4 is a perfect square, 5 is left, and we said the a and b go here. What do I wind up with now? 2 what? You said it wrong, but I think you meant it right.
2 radical
5. Okay. You get 2 square root of 5ab over 4ab squared. Narina, ask a question.
Yeah, I was just wondering the 4ab squared, why the a wasn't squared.
Okay, that came out of right here.
Yeah.
So we took the square root of 16 was 4.
Right.
What's the square root of a squared? We half the exponent, we get a, right? What's the square root of b to the 4th? That's why, to be honest, that's why I said I'd take it to the side. Having this all in this mixture is really hard to see at this stage in your life. I think the next one we're going to do that way, actually.
So the variables are the ones that you can't bring the square root of, or you would
Say that again.
the top one 4, and the square root of 5ab.
Right, both the A and the B had to go here. We couldn't pull an even number of A's. There wasn't any. There weren't any.
So it has to go to the bigger number, or
No, it just has to go in the non-perfect squares.
okay, got it.
Perfect squares have to go in here. Okay, so now we're ready to simplify the fraction. The factors of the numerator are 2 and the square root of 5ab. Okay? The factors of the denominator, we have 4a and b squared. Clearly, 2 goes into this once, 2 goes into this twice. What about the a's and b's? Can we cancel anything? No. These guys are in jail, these guys are not. There's no consorting.